1F using shielded metal arc welding.
Objectives. At the end of this topic, you will be able to mark both internal and external circles on a square plate and cut the internal and external circles using gas cutting. Insert an MS pipe into the internal circle and tack weld it. Weld the pipe to the flange using the arc welding process in the 1F position, rolling. Clean the joint using a steel wire brush. Inspect the weld bead for any external defects. Here is a list of the tools required for the pipe flange joint on an MS plate with an MS pipe of 50 mm by 3 mm wall thickness 1F using the shielded metal arc welding process. Steel rule, scriber, prick punch, ball peen hammer, flat file, bench vise, tri-square, tongs, chipping hammer, steel wire brush, electrode cable and earth cable, electrode holder, electrode, personal protective equipment, SMAW welding plant machine and their setup accessories, C-clamp. Now let's examine the pre-welding preparations for a pipe flange joint on an MS plate with an MS pipe measuring 50 mm by 3 mm in wall thickness 1F. Acquire a full-length MS pipe with a 50 mm diameter and 3 mm wall thickness. Use a ruler and scriber to mark a 50 mm length on the MS pipe. Cut the MS pipe using a hacksaw. Deburr the edges with a file and ensure a clean finish. When tacking the pipe with the gas cut flange, ensure it's maintained perpendicularly. Use a 4 mm diameter electrode for tacking. Set the current to 120 amps. Perform the tacking at 4 places on the other side of the flange joint. Maintain a fillet size of 3 to 3.5 mm. Here are the steps to perform the welding process of a pipe flange joint on an MS plate with an MS pipe diameter 50 mm by 3 mm WT 1F using shielded metal arc welding. To weld the joint in a 1G rolling position, use a weld fixture. Secure the tack welded joint in the welding fixture. Make it convenient to weld in a 1G position and complete the weld in 4 segments 1, 2, 3 and 4. Maintain a short arc as close as possible and keep an electrode angle of 45 degrees between the plate and pipe surfaces. Follow the weld sequence to help control distortion. Begin by welding the first segment 1 in the downhand position. Deslag the weld bead with a chipping hammer. Clean the weld with a steel wire brush. Rotate the joint by 180 degrees and weld segment 2 in the downhand position. Deslag the weld bead with a chipping hammer. Clean the weld with a steel wire brush. Weld segment 3 by rotating the joint on the fixture to bring the segments for welding in the downhand position. The weld deposit should cover about 10 mm of distance over the previous deposit to ensure crater filling and continuity in the root penetration. Deslag the weld bead with a chipping hammer. Clean the weld with a steel wire brush. Similarly, weld segment 4 by rotating the joint on the fixture to bring the segments for welding in the downhand position. The weld deposit should cover about 10 mm of distance over the previous deposit to ensure crater filling and continuity in the root penetration. Deslag the weld bead with a chipping hammer. Clean the weld with a steel wire brush. Check the fillet size with a weld gauge. Now, we will discuss the important points to follow for a pipe flange joint on an MS plate with an MS pipe of 50 mm diameter and 3 mm wall thickness 1F using shielded metal arc welding. Ensure that the necessary safety precautions for gas cutting are diligently followed. Verify that the pipe is positioned at a 90-degree angle to the plate surface while tacking. Ensure proper crater filling at the end of each segment during welding. Implement appropriate safety precautions during arc welding and deslagging. Let's also consider the defects that can be identified during the inspection process. Cracks. Spatters. Improper bead. Undercut. Improper fusion.
Recap. In this topic, you have learned how to mark both internal and external circles on a square plate and cut them using oxyacetylene gas cutting. Insert an MS pipe into the internal circle and tack weld it. Weld the pipe with the flange by arc in the 1F position. Clean the joint with a steel wire brush. Inspect the weld bead for any external defects. Welcome students. In this topic, we will delve into the process of welding a butt joint on an MS pipe with a 50 mm diameter and 5 mm wall thickness in a 1G position using the shielded metal arc welding process.
Objectives. At the end of this topic, you will be able to cut and bevel the pipe according to the provided drawing. Tack the pipe in preparation for butt welding. Deposit the root, second and third runs using the weaving technique and rotation method. Clean the weld bead with a steel wire brush. Inspect the weld bead for any surface defects. Here is the list of tools required for welding a butt joint on an MS pipe with a diameter and 5 mm wall thickness in a 1G position using the shielded metal arc welding process. Steel rule, scriber, prick punch, ball peen hammer, flat file, bench vise, tri-square, tongs, chipping hammer, steel wire brush, electrode cable and earth cable, electrode holder, electrode, personal protective equipment, SMAW welding plant machine and their setup accessories, C-clamp. Now, let's examine the pre-welding preparations for a pipe butt joint on mild steel pipes, each with a length of 75 mm, outer diameter of 50 mm and a wall thickness of 5 mm in a flat or downhand position, 1G, rolling. Wear protective clothing. Take a full-length MS pipe with an outer diameter of 50 mm and a wall thickness of 5 mm. Ensure that the mild steel pipe meets the correct specifications and quality standards. Inspect the pipe for any surface defects or irregularities. Ensure the mild steel pipe is clean and free from dust, dirt, grease, or any contaminants that could affect the weld quality. Accurately measure and mark the pipe for a length of 75 mm for 2 pipes. Use a marker or scribe for clear and visible marks during the cutting process. Cut the pipes to the specified size using a hacksaw. Check the squareness of the pipe end with a tri-square. File the pipe end to make it square with the pipe axis. Grind the edges to create a bevel of 30 to 35 degrees while maintaining a 1.5 to 1.75 mm root face. Remove burrs and rust from the pipe ends. Arrange the 2 pipes to form a butt joint. Align them using a fixture or a V profile of an angle iron. Use a 3.15 mm medium coated MS electrode, BIS code ER4211. Set the current to 110 amps for tacking. Before aligning the pipes on the V profile of an angle iron, set the pipes in a butt position with a 2 mm root gap. Tack weld at 4 segments at regular intervals, adjusting the 2 mm root gap between the pipes using spacers. Ensure that each tack weld ends with a keyhole. Use a tri-square to check that the pipes are in line after tacking. Visually inspect the tack welding for any defects. Now, let's explore the welding process for the pipe butt weld butt joint on mild steel pipes, each with a length of 75 mm, an outer diameter of 50 mm and a wall thickness of 5 mm in a flat or downhand position 1G, rolling. Set the tack welded pipes in a V-profile angle iron on the table. Position the V-profile on the table for welding in a flat or downhand position. Wear appropriate personal protective equipment (PPE) such as welding gloves, a welding helmet with the proper shade of the lens, and flame-resistant clothing. Inspect welding cables for any damage or exposed wires. Ensure the welding machine is properly grounded. Check the welding torch for any defects. Ensure the electrode is correctly positioned in the torch. Set the current to 110 amps for a 3.15 mm diameter electrode for the root run. Place the electrode in the holder at a 90-degree angle or a 45-degree angle away from the end of the holder. Strike the arc on the bevel at approximately 3 o'clock. Carry it down to 4 o'clock, pausing for the root face to melt and a keyhole to form. Then reverse your electrode direction. To run the first pass uphill, similar to a welding plate in the vertical position, use an electrode with a push angle of 5 to 15 degrees upward. Whip upward without damaging the pipe's surface on either side of the V groove. Stop when you reach 1 o'clock. Clean the bead thoroughly. Turn the pipe 1/4 of a turn. Proceed welding in the same manner. Repeat this process for all 4 quarters of the pipe to complete the first pass. Start the next electrode slightly below the crater. Use the keyhole technique for root penetration. Remove slag thoroughly from the root. Use a 3.15 mm electrode for the second pass, hot pass. Weld the second pass using either a triangle motion or an alternate weave, similar to vertical plate welding. Weld the third pass, known as the cover pass, following the same pattern as the second pass. The sequence should be root pass, hot pass and cover pass. Adhere to the maximum root and face reinforcement shown. When completing a pass, overlap slightly and break the arc by slowly drawing it away from the puddle. Pause at the sides of the joint to burn out any entrapped slag and fill in any undesirable undercut. Clean the weld bead with a steel wire brush. Inspect the joint for any surface defects. Here are the precautions to follow and the defects to be aware of when performing a pipe butt weld butt joint on MS pipes with a 50 mm outer diameter and 5 mm wall thickness in position 1G rolling. Avoid over deposition and side undercut by maintaining the proper angle and travel speed of the electrode. Always wear protective clothing. Use tongs to hold the hot job. Take care to pause at the sides of the joint. Let us look at the defects which can be identified during the inspection process. Undercut. Lack of penetration. Entrapped slag. Cracks.
Recap. In this topic, you have learned the following key skills and techniques: cutting and beveling the pipe according to the drawing, tacking pipes in preparation for butt welding, depositing the root pass, second pass and third pass using weaving and rotation methods, cleaning the weld bead with a steel wire brush, inspecting the weld bead for any surface defects to ensure the quality and integrity of the weld. Welcome students! In this topic, we will learn about fillet lap joints on a 10 mm thick MS plate in the overhead position 4G using the shielded metal arc welding process. Let me provide you with a brief introduction to fillet welds. A fillet weld is a type of weld used to join two pieces of metal at an angle, typically a 90-degree angle, creating a triangular cross section. Shall we now delve into overhead welding? Yes, overhead welding is often considered one of the more complex and demanding welding positions due to the increased risk of issues such as weld spatter, slag inclusion, and difficulty in achieving proper penetration.
Objectives. At the end of this topic, you will be able to Prepare plates as per the size 150 mm length, 50 mm width and 10 mm thickness. Set the plates in the form of a lap joint and tack weld at each end of the joint at an equal distance. Deposit the root, second and third runs using the weaving technique in an overhead position. Clean the weld bead with a steel wire brush. Inspect the weld bead for any surface defects. In addition to the above objectives, the following points should be kept in mind before starting the welding of a fillet lap joint in an overhead position. The welding machine should be set to the correct voltage and amperage for the thickness of the material being welded and the type of electrode being used. The electrode should be held at the correct angle and travel speed to produce a smooth, uniform weld bead. The weld pool should be kept small and molten to avoid slag incursions and porosity. The slag should be removed from each bead before depositing the next bead. Here is the list of tools and equipment essential for ensuring the safety of the welder and the quality of the fillet lap joint in the overhead position on a 10 mm thick MS plate 4G. Steel rule, scriber, prick punch, ball peen hammer, flat file, bench vise, pry square, tongs, chipping hammer, steel wire brush, electrode cable and earth cable, electrode holder, electrode, personal protective equipment, SMAW welding plant machine and their setup accessories, C-clamp, wear protective clothing, use plain goggles while grinding and welding goggles while gas cutting. Take an MS plate. Ensure that the mild steel plate meets the correct specifications and quality. Inspect the plates for any surface defects or irregularities at the edges. Ensure that the mild steel plate is clean and free from rust, dirt, grease or any contaminants that could affect the quality of the weld. If any contaminants are found, clean the plate with a chemical cleaning compound and remove rust and dirt with a steel wire brush. Apply the marking medium like chalk to the MS plate. Wait for a few minutes for the marking medium to dry. Mark the length of the plate as 150 mm using a ruler and a scriber. Mark the width of the plate as 50 mm using a ruler and scriber. Punch mark the lines using a prick punch and a hammer on the length measurement side. Do the same for the width side measurement. Begin the cutting process using a gas cutter. Set up the oxyacetylene cutting setup for gas cutting the MS plate. Set the working pressure for oxygen and acetylene. Cut the plates using gas cutting to achieve the dimensions 150 mm length, 50 mm width and 10 mm thickness. Deburr the edges using grinding. Check the squareness of the plates. Clean the surface of the plates with a steel wire brush. Set the plates as a lap joint with a lapping distance of 20 mm. Place the plate on the welding table in preparation for the welding process. Start setting up the SMAW machine. Keep the SMAW machine at a safe distance to avoid electrical shock. Ensure that the earth clip is in proper working condition. A malfunctioning earth clip can adversely affect the welding process. Ensure you have the correct electrode for welding. If unsure about the electrode's specifications, refer to the guidelines provided. Select a 3.15 mm diameter MS electrode and have it ready to connect with the welding torch. Ensure the welding torch is functioning correctly. Inspect the electrode holder in the welding torch for any issues. If problems are found, address them. Check the connecting wires at both ends. Examine the cables for any cuts or deformities. If issues are found, use electrical insulation tape to rectify the problem. Connect one end of the electrical cable to the welding torch and the other end to the SMAW machine. Ensure that the cables are securely fastened in the SMAW machine and welding torch. Verify the machine setup before commencing the welding. Begin by checking the power supply of the SMAW machine. Set the correct amperage for the welding in the SMAW machine. Ensure that the amperage is set correctly for the fillet weld. If uncertain about the amperage, refer to the guidelines and adjust it accordingly for the welding process. Set the current to 110 amps for tack welding. If the machine is functioning properly, perform an arc test on a sample plate. Position a welding torch fitted with an electrode near the lap joint on the welding table. Tack weld the plates at both ends with a 3 mm tack size. Inspect the tack weld for any surface defects.
Recap. In this topic, you have learned the following key skills and techniques. Prepare plates as per size 150 mm length, 50 mm width and 10 mm thickness. Set the plates in the form of a lap joint and tack weld at each end of the joint at an equal distance. Welcome students. In this topic, we will learn about fillet lap joints on a 10 mm thick MS plate in the overhead position 4G using the shielded metal arc welding process.
Place the welding positioner table in a secure location with ample space for the welder to move. Familiarize yourself with the controls of the welding positioner, including the speed of rotation and direction to facilitate easy and precise positioning during welding. Use appropriate clamping devices such as C-clamps or magnetic clamps to securely hold the 10 mm MS plate in position on the table. Ensure the clamps provide sufficient pressure to prevent movement during welding. Adjust the positioner's stable angle to the overhead welding position. This angle should be set to match the desired welding position. Fix the tack welded lap joint in the overhead welding positioner with a provided clamp. Center the tack welded lap joint along the axis of the positioner to maintain balance and stability during rotation. Position the plates so that the welding area is easily accessible, allowing the welder to maintain good visibility and control over the welding process. Ensure that all safety precautions are in place, such as guarding to protect against sparks and proper grounding of the positioner to prevent electrical hazards. Wear appropriate personal protective equipment PPE, such as welding gloves, a welding helmet with proper shade of the lens, and flame-resistant clothing. Inspect welding cables for any damage or exposed wires. Ensure the welding machine is properly grounded. Check the welding torch for any defects. Ensure that the electrode is correctly positioned in the torch. Select a 3.15 mm dia MS electrode for welding the root run. Set the current to 110 amps for the root run. Hold the electrode so that it bisects the angle between the edge of the top plate and the surface of the bottom plate. Lay the first bead at the root of the joint with a short arc without electrode weaving. Remove the slag from the bead using a chipping hammer. Clean the weld bead with a steel wire brush. Use a 3.15 mm dia MS electrode for the second run. Set the current to 110 amps for the second run. The electrode angle is the same as the one mentioned for the root run. Deposit the second run with a stringer bead technique. Deslag the weld bead with a chipping hammer. Clean the weld bead with a steel wire brush. For the third run, use a 3.15 mm dia MS electrode. Set the current to 110 amps for the third run. Deposit the third bead in between the first bead and the bottom edge of the top plate. With a short arc and with an electrode angle of 45 degrees to the surface of the plate to avoid the edge melting off the top plate. Deslag the weld bead with a chipping hammer. Clean the weld bead with a steel wire brush. Inspect the weld for any surface defects. Here are the guidelines to follow for a fillet lap joint on an MS plate with a 10 mm thickness in an overhead position using the shielded metal arc welding process. Always wear protective clothing. Wear a proper helmet. Ensure proper electrical safety. Prepare the joint properly. Use the correct welding parameters. Maintain a proper arc length. Use a weaving motion. Travel at a steady pace. Clean the slag after each pass. Make sure that the weld bead is properly sized. Use tongs to hold the hot job. Let's now examine the defects that can be identified during the inspection process. Undercut. Porosity. Uneven ripples. Edge of the plate melting off. Cracks.
Recap. At the end of this topic, you will be able to prepare plates as per size 150 mm length, 50 mm width and 10 mm thickness. Set the plates in the form of a lap joint and tack weld at each end of the joint at an equal distance. Deposit the root, second and third runs using the weaving technique in an overhead position. Clean the weld bead with a steel wire brush. Inspect the weld bead for any surface defects. Welcome students. In this topic, we will learn about a single V butt joint on an MS plate 10 mm thick in the overhead position 4G using the shielded metal arc welding process.
Objectives. At the end of this topic, you will be able to Prepare the plate as size 150 mm length, 50 mm width and 10 mm thickness. Beveld plate with root gap and tack the weld joints. Clamp the tack welded plates in overhead welding positioner. Deposit root run, second run, third run. Clean the weldment with steel wire brush. Inspect weldment for any surface defects. Here is the list of tools and equipment required for the single V-butt joint on an MS plate 10 mm in overhead position 4G using shielded metal arc welding. Steel rule, scriber, prick punch, ball peen hammer, flat file, bench vise, pry square, tongs, chipping hammer, steel wire brush, electrode cable and earth cable, electrode holder, electrode, personal protective equipment, SMAW welding plant machine and their setup accessories, C-clamp. Let's explore the pre-welding preparations for a single V-butt joint on 10 mm thick MS plates in an overhead position using the shielded metal arc welding process. Wear protective clothing. Use plain goggles while grinding and filing. Take an MS plate of 200 mm length, 100 mm width and 10 mm thickness. Ensure the mild steel plate meets the correct specifications and quality. Inspect the plates for any surface defects or irregularities at the edges. Ensure the mild steel plate is clean and free from rust, dirt, grease or any contaminants. Apply a marking medium like chalk over the MS plate. Wait for a few minutes for the marking media to dry. Mark the length of the plate as 150 mm using a ruler and scriber. Mark the width of the plate as 50 mm using a ruler and scriber. Punch mark the lines using a prick punch and a hammer on the length measurement side. Do the same for the width side measurement. Secure the job on the bench vise. Check the hacksaw blade for sharpness. Ensure the correct blade size for the 10 mm MS plate. Begin the cutting process using a gas cutter. Set up the oxyacetylene cutting equipment for gas cutting the MS plate. Adjust the working pressure for oxygen. Adjust the working pressure for acetylene. Cut the plates using gas cutting to achieve the dimensions 150 mm length, 50 mm width and 10 mm thickness. Grind or file a 2 mm root face on each beveled edge. Thoroughly clean the pieces to be joined. Use spacers to maintain a 2.5 mm root gap. Set up the SMAW machine with a welding torch for tack welding. Use a 3.15 mm dia MS electrode for tack welding. Set the current to 110 amps for tack welding. Tack weld the plates at both ends with a 3 mm tack size. Inspect the tack weld for any defects. Let's examine the welding process for a single V-butt joint on an MS plate 10 mm thick in the overhead position 4G using shielded metal arc welding. Clamp the tack welded single V-butt joint in an overhead welding positioner. Wear appropriate personal protective equipment (PPE) such as welding gloves, a welding helmet with the proper shade of lens, and flame-resistant clothing. Inspect welding cables for any damage or exposed wires. Ensure that the welding machine is properly grounded. Check the welding torch for any defects. Ensure that the electrode is correctly positioned in the torch. Select a 3.15 mm dia MS electrode for welding the root run. Set the current to 110 amps for the root run. Keep the electrode as close as possible to the surface of the plate and at a slight angle to the direction of the weld. Position the electrode well up in the gap and control the keyhole to achieve a small reinforcement on the root side. Deposit the root run with a short arc and uniform welding speed to achieve consistent root penetration. Clean the weld bead with a steel wire brush. Use a 3.15 mm dia MS electrode for the second run. Set the current to 110 amps for the second run. Maintain the same electrode angle as for the root run. Deposit the second covering run with a weaving motion. Clean the weld bead with a steel wire brush. For the third run, use a 3.15 mm dia MS electrode. Set the current to 110 amps for the third run. Deposit the third covering run similar to the second run. Clean the weldment with a steel wire brush. Inspect the weld for any surface defects. We will explore the important points to follow for a single V-butt joint on 10 mm thick MS plates in an overhead position using the shielded metal arc welding process. Maintain a short arc length with a multi-layer approach. Avoid over-deposition and side undercut by using the proper angle and travel speed of the electrode. Use tongs to safely hold the hot workpiece. Prevent the upper edge of the plate from melting off. Wear chipping goggles for eye protection. Now, let's identify the defects that can be observed during the inspection process. Undercut. Cracks. Improper bead profile. Poor fusion. excess reinforcement.
Spatters.
In this topic, you have learned to prepare the plate to the size of 150 mm length, 50 mm width and 10 mm thickness. Bevel the plate with a root gap and tack the weld joints. Clamp the tack welded plates in an overhead welding positioner. Deposit the root run, second run and third run. Clean the weldment with a steel wire brush. Inspect the weldment for any surface defects. Welcome students. In this topic, we will learn about the butt joint of a half-inch copper pipe through the brazing process using induction welding.
Objectives: cut the copper pipes according to the given specifications. Brazing the copper pipes using the induction method. Clean the weldment using a steel wire brush. Inspect the weldments for any surface defects. Here's the list of tools and materials required for the butt joint of a half-inch copper pipe by the brazing process using the induction welding method. Materials: copper tubing with a half-inch or 12.5 mm outer diameter. Stainless steel Teflon-coated mandrel with a 1/8 inch 3.18 mm diameter. Equipment: 6 kilowatt induction heating system. Remote workhead containing two 33 Fahrenheit capacitors, total of 66 Fahrenheit. Coils: induction heating coil designed and developed specifically for this application. Here are the pre-welding preparations for a butt joint of a half-inch copper pipe by the brazing process using the induction welding method. Take a long copper tubing with a half-inch diameter, 12.5 mm outer diameter. Accurately measure and mark the pipe for a 75 mm length for two pieces. Use a marker or scribe to create clear and visible marks for guidance during the cutting process. Cut the pipe to the given size using a hacksaw. Prepare a stainless steel Teflon coated mandrel with a 1/8 inch 3.18 mm diameter. Remove any sharp edges or burrs from the pipe ends to create a smooth and even surface for proper contact during brazing. Ensure that both the interior and exterior surfaces of the copper pipe are thoroughly cleaned. Use a wire brush or abrasive cloth to remove any dirt, grease or oxidation that could hinder the brazing process. Ensure precise alignment and fit up of the copper pipes before brazing to minimize gaps and ensure a strong joint. Use braze alloy Cu P7 rods for brazing. Apply an appropriate flux to the joint area. The flux prevents oxidation during heating and promotes the wetting of the filler material. Make sure the flux covers the entire joint area evenly. Place the pipes within the inductor coils of the induction welding machine, ensuring they are positioned correctly and securely. Proper alignment is crucial for uniform heating. Position temperature sensors such as thermocouples at strategic points on the joint. These sensors help monitor and control the brazing temperature. Set the appropriate power and frequency settings on the induction brazing machine. These parameters will depend on the thickness of the copper pipes and the type of filler material being used. Initiate the induction welding process with a preheating stage to bring the pipes and joint area to a uniform temperature, minimizing thermal shock during the main brazing process. Visually inspect the joint area before the main brazing phase to ensure that the pipes are properly aligned. Use a brush or a suitable applicator to spread the flux evenly. Make any necessary adjustments before proceeding with the brazing process. Let us take a look at the welding process for the butt joint of a 1/2-inch copper pipe by the brazing process using the induction welding method. Position the inductor coils of the induction brazing machine accurately to focus the electromagnetic field on the joint area. Proper coil placement ensures efficient and uniform heating. Begin the brazing process with a preheating stage. Gradually raise the temperature of the joint area to a point just below the melting temperature of the filler material. This minimizes thermal stress during the main brazing phase. Introduce the brazing filler material, which is the brazing alloy Cu P7 rod for brazing the joint. The filler material should be distributed evenly along the joint interface. Increase the power and frequency settings on the induction brazing machine to heat the joint area to the melting point of the filler material. The filler material should flow and wet the joint surfaces, forming a strong bond. Maintain control over the heating process to avoid overheating and burning of the flux or the base metals. Monitoring the temperature using sensors is crucial. Capillary action draws the molten filler material into the joint by surface tension. Ensure that the joint is designed with proper clearances to allow capillary action to occur effectively. Monitor the joint temperature and ensure that the entire joint area is heated evenly. This prevents weak spots and ensures a consistent bond. Be mindful of potential distortion due to temperature changes. Properly fixturing or supporting the pipes can help prevent warping or misalignment during the brazing process. After the brazing is completed, allow the joint to cool down. Clean the joint area to remove any residual flux using appropriate cleaning methods. Inspect the brazed joint for quality. Look for uniform fillets and proper bonding. Conduct a visual inspection which can help you verify the joint's integrity. Now, we will look at the important points to follow for the butt joint of a 1/2 inch copper pipe by the brazing process using the induction welding method. Protective gear. Wear appropriate personal protective equipment (PPE), including heat-resistant gloves, safety glasses, or a full face shield, and flame-resistant clothing. This gear safeguards you from potential heat, sparks, and harmful fumes. Ventilation. Perform brazing in a well-ventilated area or use exhaust systems to remove fumes and gases generated during the brazing process. Proper ventilation helps maintain a safe working environment and prevents the buildup of hazardous fumes. Fire safety. Having fire extinguishing equipment, fire extinguisher or sand bucket readily available in case of accidental fires. Ensure that there are no flammable materials near the brazing area and have a clear plan for extinguishing potential fires. Let's look at the defects which can be identified during the inspection process. Incomplete fusion. Lack of penetration. Overheating and burn through. Oxidation and contamination. Excessive fillet size.
Recap. In this topic, you have learned to cut the copper pipe as per the specifications provided, braze the copper pipes using the induction method, Clean the weldment using a steel wire brush. Inspect the weldments for any surface defects.
Good morning, ladies and gentlemen. Today we come to the next phase of our discussion on sustainable development. To take a case in point, nowadays when they design an IIT or an IIM, there is a huge discussion